Alright, so this is another continuation video from Baeyer Villiger Oxidation. And here are two sets of questions for you. I want you to pause the video, draw the mechanism for each reaction and find out the product. So let's go ahead and solve each reaction. Okay, so in the first question, we have a cyclobutanone derivative. And we are reacting this with this particular reagent, and we are getting some product. So let's draw the mechanism. So I have this cyclobutanone. This carbon right here is electron deficient, having delta positive charge. And this oxygen is electron rich and having delta negative charge. The another reagent is this one. Now this nitrogen has a pair of electron. This oxygen have two pair of electrons. But this oxygen lone pairs are busy in resonance with this system. But this nitrogen lone pairs are free to attack. So that's why they will go ahead and attack at this carbonyl carbon, opening up this bond. So this will give me O minus NH O P double bond O PH and PH. Now this is a type of Baeyer Villiger oxidation, and we know one of the bond is going to migrate. And as discussed in my previous video, we know the more electron density cloud carbon will migrate. So we have two carbons to migrate. One is this and one is this. And the carbon which has more electron density will migrate. So at this carbon, we have an extra methyl group, extra plus I donating group that will create more electron density at this center. So that's why this particular carbon is going to migrate. So when this oxygen reform a double bond, this bond is going to migrate towards nitrogen and this group is going to leave. So this will give me, so let's number them. So I'm writing this one as 1, this is 2. Now this nitrogen is bonded with this carbon right here. So this is 3. This one is 4 and this one is 5. So we have formed a 5-membered ring. So this will be the product. So this is my carbonyl carbon number 1 that is bonded with NH number 2. This particular bond has migrated towards nitrogen, so this carbon will get number 3, which has this methyl group. 3 is bonded with 4, which has this pH group, and 4 is bonded with 5, which is ACH2. So this is the product for this particular reaction, and this is the reaction mechanism. Now let's solve the second question. Okay, so let's solve the second question. So we have reagent as BF3, hydrogen peroxide under basic condition, and we are getting some product. Now we know when we have hydrogen peroxide under basic condition, the HO minus ion coming from this hydroxide ion will take this proton and will generate alkoxy ion. So this will give me HOO minus. So this is my starting material, and we know BF3 is a Lewis acid. So this oxygen will do chelation with BF3, and this will generate this one. So we have H2O2. Under basic condition, HO minus will grab this proton, will generate alkoxy ion. Then in the first step, this oxygen does the coordination with this Lewis acid BF3 and get partial positive charge. Now this oxygen lone pairs will form double bond here, and this bond is going to break. And this will give me this one. Now this oxygen having positive charge, and we have this oxygen with negative charge. So this will attack at this carbonyl, and this bond is going to break. So this will give me and this OBF3 will be hydrolyzed into OH. So we have generated this particular intermediate. Now we have bases in our reaction, and we have this proton here, correct? So one of the proton can be abstracted. So this HO minus will take this proton. This will form double bond here, and this whole group is going to migrate towards this oxygen, breaking this bond. Now why particularly this bond is migrating? So this is a Baeyer Villiger type of reaction, and at this carbon we have more electron density as compared to simple R3. So that's why this whole group is migrating towards oxygen, and this bond is getting break. So this gives me so this bond is no more, okay, but we have still this bond, and now this is connected with this. And rest will be same. And if you look closely, we have got the product. So this is the product for this particular reaction. If I redraw it, the product will look like something this one. So we have ester here. So this is the final product for this reaction. So let me just recall my reaction mechanism. So when hydrogen peroxide in presence of base will generate this HOO minus, where this HO minus will take the proton of hydrogen peroxide. We have a Lewis acid, so this oxygen is going to chelate with this BF3, will generate this positive charge. Then another oxygen will reform double bond, and this bond is going to break, and we generate this particular system. So we have generated a sort of carbonyl carbon. So this oxygen with its lone pair will attack at this carbon center and will neutralize oxygen. We have plenty of bases. So one of the base, this HO minus, will take this proton. This bond will form double bond here, and this particular group or this bond is going to migrate towards oxygen because electron density is more at this carbon, and this OH is going to leave. And this is how, if I perfectly write it, this is my product. So final product is just after doing this step. So this is the product for this reaction. So thank you for watching, and do share with your friends.